God bless you, geometry students, and welcome to another practice geometry quiz. This one is pertaining to our upcoming quiz for tomorrow, Thursday. Uh, this will be March 19th or March 20th. All right, we're going to start off with our foundational scripture taken from Proverbs 4:23. I'm sure you already know this. If not, you should know it very, very quickly. It's from the last time. It says, keep, in most versions, your heart. And that's the center of all things. We're studying a lot to do with centers and bisectors right now. And it is with all diligence. For out of it should be an it, spring the issues of life. So we should think about that as we think about angle bisectors, perpendicular bisectors, because those are going right through the heart of uh, angles or sides that we study. And now, our first bisector we're going to be studying is in number 1, where it says, find the value of x. Identify the theorem used to find the answer. So we're going to find x. Here they give us the length of this segment here. It's 9x minus 4. And the length of this one is 9x plus 5x plus 8. So let's take a look at that. What do we have here? We have an angle bisector. This ray is an angle bisector. It bisects this big overall angle into two congruent angles. At any point on the angle bisector, point T or any of these points here that I'm dotting right now, the perpendicular distance from that point to each of the sides making up the angle will have to be equal. That's what the theorem says. So therefore, 9x minus 4 will have to be equal to 5x plus 8. Okay? And this is some good algebra for you. You're going to be doing algebra 2 next year, so I want to get you as ready as possible. Here we're going to subtract 5x from both sides. I'm going to treat you somewhat like your algebra teacher will treat you when you subtract 5. That's going to be gone. 9 take away 5 over here would be 4. So this would be 4x minus 4 equals 8. We take another step. We'll add 4 to both sides. So when we add 4 to this side, that negative 4 is gone. So the only thing that survives on the left would be 4x equals 8 plus 4. That would be 12. We divide both sides by 4. This becomes x. 12 divided by 4 would be 3. So that would be our answer for the first one, x equals 3. And I'll handle the theorem afterwards. Here comes number 2. Number 2, we have a segment here that's bisecting the big angle into two congruent angles. We have a segment over here, this one, that bisects this big overall angle into two congruent angles, namely this angle and this one. And the same thing happens to this big angle down here. It's bisected into two congruent angles. So we're coming right through the heart of these angles. And the point of concurrency is this point here called P. And this point, it's got a special name. I hope you remember what it is. It's called the incenter. Incenter, that's the point of concurrency of the angle bisectors. Okay? And it's called the incenter. Here's a review for you. Because if you use this as a center, this point P as a center, and this distance, or this distance, or this distance as your radius, you would get a circle inside of the triangle, and I won't draw all of it because I don't want to crowd the diagram so much, but you'll have a circle inside the triangle, and that circle would be such that this segment and this one and this one are all the same. I'm sorry, not this one. This one, this one, and this one, all the perpendicular distance segments are going to be all the same. Not that one. Again, this length, and this one all the same because they would be all radii of the same circle. Okay? So that being said, the setup here would be 3x plus 6 is equal to 8x minus 19. And this algebra is a little bit more interesting, but you can see that we subtract 3x from both sides. When we do this, 3x would be gone, and 8x take away 3x would give us 5x over here, minus 19. On the left side, we would have 6. I'm going to take a couple more steps. We'll add 19 to both sides. When we do, this negative 19 will be gone. 19 plus 6 will give us 25 over here. Divide both sides by 5, we get x equals 5. Okay, and the theorem that's covered here is the theorem pertaining to the angle bisector. So you could just write the angle bisector theorem. Okay, and it simply says that any point on the angle bisector, is such that its perpendicular distance to the sides of the angle bisected would be equal. So this would be the same as this. The same applies to over here. It's just that the incenter P is going to be the same distance from each of the sides. This will be the same, that will be the same. All right? Now let's transition over to something else. Here it says in the figure, P is a centroid. So P is a centroid of triangle XYZ. And they give us that YP is 12. Here it is, YP is 12. They give us that LX is 15. LX is 15. And finally, there should be an and here. And LZ is 18. LZ is 18. Okay, so let's show that that's 18 like this. So that's the overall here. And once you see the word centroid, you should be thinking median. So since this is a centroid, this will be a median, and the median goes through the midpoint. So M is a midpoint, and that means that NZ and XN are the same. Likewise, NL is a median, so that means that LY and XL are the same because L is a midpoint. And finally, the third median, XM, means that YM and MZ are the same, M being the midpoint. And now, let's find these lengths. Find the length of LY. LY from L to Y is going to be the same as from L to Z, so that will be 15. Distance from Y to N, Y to N. And here's what I told you about the median. The longer segment of the median, namely from Y to P, is going to be twice the shorter segment. So if this is 12, then Pn must be 6. So 12 plus 6, that would be 18 for Yn. How about the length of LP? Distance from L to P, that's a little bit tougher. They give us the overall, LZ is 18. So LP, that's 1/3 of the overall, and this is 2/3 of the overall. So LP will be equal to 1/3, as I just mentioned, of the overall, which is 18. When I cancel 3 here, and 3 goes into 18, 6. 6 times 1 would give me 6. So LP would be 6. And while I'm doing LP, I might as well do PZ, because I told you that the shorter segment is going to be a half of the longer. So if this is 6, and this has got to be 12. And finally, NP, distance from N to P. Well, the longer segment of the median is 12, so the shorter segment would be half of that. That will also be 6. Okay, so that's a little review there on the medians of a triangle that converge or intersect at a point called the centroid. Next on the list here, we've got the list of sides of the triangle shown from smallest to longest. And what I told you was that I should say shortest to longest. The shortest side will be opposite to the smallest angle, and the longest side will be opposite to the largest angle. So we're given two angles here. We can find the missing one very easily. We add 105 with 45, we get 150. So the missing angle is going to be 180 minus 150 by the angle sum theorem here. So this missing angle here would be 30 degrees. And if you look for a while, you see that's the smallest angle. So the shortest side would be opposite or across from that. Shortest therefore would be GO, segment GO. Next in line would be the 45-degree angle, and that's straight across from OD. So OD would be the middle in terms of length, and the longest is going to be opposite the biggest angle, so it's going to be straight opposite to it, or it's going to be segment GD. Okay. Conversely, or similarly, if we want to find the angles of the triangle shown below from smallest to largest, we will look for the shortest side. The shortest side is this one, so the smallest angle is going to be opposite to that one. That's going to be angle Y. What would be the middle-sized angle? The middle-sized angle is going to be this one, 12. Sorry, this is the middle-sized length. So the middle-sized angle would be opposite that. That's going to be angle X. And finally, the largest angle would be opposite to the longest side. Longest side is 13, so the largest angle would be angle Y. Okay, so that would take care of inequalities in a triangle like that. And I will make another short video just to cover the inequalities that deals with the side lengths and the possible side lengths of a triangle.